Here's the next part of your notes for last week. I know you have been waiting patiently and are way excited for it. This next section is all about graphing, and I sent a PowerPoint that it discussed these types of graphs as well as what their equations look like. So make sure you took a look at that. The one that I don't have here is cubic functions, and cubic functions have this sort of shape. Okay, so these would be cubic functions or cubic graphs, right? So make sure you know these types of graphs, what they look like, and what their equation would look like. So the next set of questions are going to ask you, determine the following are linear, quadratic, exponential, or logarithmic. I think the easiest way to solve these problems is to actually plot these points. And then based off of the shape of their graph, decide which it is. Okay? So I'm going to treat this as my x value and this is my y. So this is the point -1, 1. This is the point 0, 0. This is the point 1, 1. And this one is the point 2, 4. So I want to graph these, and based off of the shape, we will decide which type of graph it is. So -1, up 1, to the left and then up. 0, 0, 0 over, 0 up. 1 to the right, 1 up. 2 to the right, 4 up. And if I graph these, I start to get, and I can imagine that it would continue over here, and it would continue up, and I start to get which shape? A quadratic shape. Okay. So this would be quadratic. It's not exponential because you can tell here that it is going up, so not just down to the side. So it's not exponential. This would be quadratic. Graph those points, see the shape. Okay. Let's try this one. Same thing. I'm going to graph these points. Okay. This is going to be the point 3, 5, 4, 7, 5, 9. So 3 over, 5 up, 4 over, 7 up, 5 over, 9 up. And if I connect these, it's a straight line, which means it is a linear function, a linear graph. So plot those points on the graph and decide what shape it is. You will need to know what these are. So make sure you are studying these. You're going to have to know these 5 different types of graphs, what they look like and what their names are. The next set talks about slope, and that is just the angle at which your line is increasing. Okay? So the slope of the line, how steep is it? To find slope, if you remember rise over run, you're going to subtract your y values, so up and down, and then run side to side. Okay, so subtract your y's, subtract your x's. So you're going to need to memorize this formula. Okay, up and down, subtract how you're changing, up and down, subtract how you're changing right to left. A positive slope goes up to the right, negative slope goes down to the right or up to the left. So find the slope of the lines that contain the following points. So we're going to practice finding slope. Right. And it looks like a fraction. And the first thing you need to do is subtract your y values. How is it changing up and down? It doesn't matter which one you pick first, except for on bottom. If I picked 3 first on top, I must pick 5 first on bottom. 3 minus 8, negative 5. 5 minus 2, 3. So the slope of this line is negative 5 over 3. Right? It has a negative slope, that goes up 5 or down 5 to the left 3, either one. This next one, same thing. It does not matter which one you choose first on top, as long as you are subtracting your y's. Remember, up and down, how does it change? So 7 minus 12. If I pick 7 first, I must pick 2 first. 2 minus 9. Okay. 7 plus negative 12, negative 5. 2 minus 9, negative 7. Since it's a negative over a negative, that is the same as positive 5 over 7. So this one goes up 5 to the right 7. Subtract your y's, then subtract your x's. This next example asks you to find the slope of the line. And so they don't give you 2 points. So I need to find 2 points on the graph. Okay? Looks like I have a point here, a point here. Where is it crossing? And a point here. I just need to pick 2 of those points. And I'm going to use those to find the slope. Okay? So I have the point 0, 3. I also have the point 3, 2. Okay? So 0 right or left, up 3, 3 to the right, up 2. You could have used negative 3, positive 4 as well. That would be also acceptable. I'm going to use these 2 points, and it doesn't matter which one I choose first, top or bottom, but I must choose the y values. So 3 minus 2. Since I picked this one first, I must pick 0. I already know, looking at this, that I'm going to have a negative slope, so my answer should be negative. 3 minus 2 is 1. 0 minus 3 is negative 3. So it goes up 1, left 3. Up 1, left 3. Okay? You can see that pattern. Up 1, left 3. So negative 1 over 3, or 1 over negative 3. Subtract your y's. Then subtract your x's. The last portion, a little bit more graphing. When we look at these, a solution is where the graph crosses the x-axis. You're going to be asked to find solutions, match them with graphs. So if I look here, it's where it crosses the x-axis. So I have, it crosses at 3, it crosses at 1, and it crosses at negative 1. Those are my solutions. Okay. In the equation, however, it's the opposite. Okay. It would be, whatever would make this should be a negative 3. X minus 3. It's the opposite of what you would think should be there. Okay? So if it crosses at 3, inside the parentheses is an x minus 3. If it crosses at 1, inside is an x minus 1. If it crosses at negative 1, inside is x plus 1. Okay? So it's the opposite of it, what's inside. So it crosses at 3, it should be x minus 3 inside. Since it is a negative out front, it ends going down. So it is going down here. Okay, when it moves to the right, it's heading down. If there's a positive in front, it ends heading up. You'll be needing to know that, especially when we are picking graphs. So you need to know positive means it heads up, negative it heads down. Same thing here. It crosses at 3, so there's x minus 3. It crosses at 1, there's x minus 1. It crosses at negative 4, x plus 4. It's the opposite inside. Okay. So number 1, how many solutions does the graph have? How many times does it cross? Once, twice, 3 times. 3 solutions. Number 2, how many times does it cross? Just once. It hits and bounces down, so that has one solution. So this is the type of problem you really need to pay close attention to. Which equation can the graph be? Notice that it heads which way? It's heading down. So immediately I can eliminate the positive ones. I know it's heading down, so I must have a negative out front. I'm not really concerned about what that value is, as long as I know it's heading down, so it must be negative out front. Next, if it crosses at 5, what should be inside? X minus 5. Remember, it's always the opposite. If it crosses at 2, what should be inside? X minus 2. If it crosses at negative 1, what should be inside? The opposite, or x plus 1. So I'm looking for the equation now that has these 3 pieces. This is a plus 2. I need a minus 2. Here's my minus 5, x minus 5, x plus 1. There's my answer. It's really important you focus on which direction does it end to the right, and then your inside parentheses are the opposite of what they cross at. Okay. Put a big star next to this problem. You need to make sure you focus on that one. This one, which equation can be the graph below? It has that shape of a cubic function. That function I told you to add in, that graph, that's a cubic function. It has that where it comes down and then it kind of swaps. Okay. They can also look like this. That's a cubic, so I'm looking for the equation that has a cube in it. And that would be right here. So my answer is C. That would be a cubic function. It has the shape of that cubic function. I promise our last section here is parallel lines. And the most important thing about parallel lines is they never cross and they have the same slope. So the number in front of x has to be the exact same. They are increasing at the exact same rate. So that number in front of x must be the same. So when it gives you an example of locating an equation parallel to this one, what piece am I looking at that must be the same? The number in front of x. This is y equals mx plus b. That value right in front of x is your slope. So I need one that has the exact same. Parallel lines have the exact same slope. So I'm looking for the equation that has a 1/2. And that only option is B. Parallel lines have the exact same slope. Yay, our last problem for this section. Okay. Which equation is parallel to the line in the graph? This time you have to combine those skills we've just been practicing. You're going to have to figure out the slope of the graph. Pick some points. Crosses here, and it crosses here. So this is the point 0, 1, and the point 5, 0. I first have to find the slope, and then I'm going to compare it to the values in front of A. Immediately, I know this is positive or negative. This is a negative slope. So immediately, I know it's not C and it's not D. This is a negative slope. It's going up to the left. So if I find the slope now, 1 minus 0 and 0 minus 5. Remember, I picked the 1 first, so I must pick the 0 first on bottom. 1 minus 0, 0 minus 5. So the slope of this line is negative 1/5. So which equation has negative 1/5 as our slope? B does. Figure out what the slope is of the line. Find the equation that has the same slope. Okay. Awesome job, guys. If you have any questions on this stuff, please let me know. I will see you Thursday night.